Hey everyone, it's Bradley Bush with another algebra video for you. Today we're talking about geometric sequences and specifically how to find the nth term of a geometric sequence. And we have 4 worked examples. If this is your first time to my channel, I'm happy you're here. If you're returning, thanks for coming back. If you find any of this useful, then subscribe to my channel, give me a thumbs up, or please leave a comment. First off, what is a geometric sequence? A geometric sequence is a sequence where each term after the first is computed by multiplying the previous term by the same non-zero constant that we call the common ratio. The common ratio can be found by taking the second term of the sequence and dividing it by the first term of the sequence. And we call that common ratio R. So if we have a sequence, say 1 is the first term in our first example, 5 is our second term. So 1 is our first term, 5 is our second term. So we can find our common ratio by taking 5 divided by 1, which gives us 5. So if you look at our sequence, we have the first term, which is 1. You multiply that by 5 and get, multiply 1 by 5 and get 5. You multiply that term 5 by 5 and get 25. That's the third term. You multiply the third term, which is 25, by 5 and get 125. So each of these terms after the first is computed by taking the previous term multiplied by 5. And here we have a geometric sequence. This geometric sequence is infinite if we only took the first n terms. Say we stopped at the nth term and we just had these first n terms, then we would have a finite geometric sequence. Our second example, we have 9 as our first term, which is a sub 1. We have negative 3, which is our second term. If we take negative 3 and we divide it by 9, we get negative 1/3. So if we go back to our sequence here, 9 is our first term, that's just given to us. We multiply that by negative 1/3, we get negative 3. We multiply negative 3 by 1/3 and we get 1. We multiply 1 by negative 1/3 and we get negative 1/3. So you can see that each of these terms is found by multiplying the previous term by the common ratio. And just a side note, a geometric sequence with the common ratio r greater than 0 but not equal to 1 is an exponential function whose domain is the set of positive integers. The general term, or the nth term, of a geometric sequence with the first term a sub 1 and the common ratio r can be written like this. A sub n equals a sub 1 times the common ratio r raised to the n minus 1. And this works for n greater than or equal to 2 because n equals 1 is given to you in any series. In any sequence. So for our example, if we're asked to find the 8th term of a geometric sequence and our first term, a sub 1, is negative 4 and our common ratio is negative 2, then we can do it. A sub 1 we said was negative 4, so let's write down negative 4 for a sub 1. And we're multiplying that by r. We say r is negative 2, so we have negative 2. And then n minus 1, n is 8, and we're subtracting 1. So that gives us negative 4, and we still have negative 2 here to the 7th power. Negative 2 to the 7th power is negative 128. So we have negative 4 times negative 128, and that gives us 512. So just in case you're curious, I wrote out the first 10 terms of this geometric sequence, and I highlighted the 8th term so you could see, and it is in fact 512. Kind of cool, huh? Let's do these 3 examples here. So first, we need to find the nth term, or the formula for a sub n, and then use that to find a sub 6, or the 6th term. And we shouldn't use the recursion formula. We should use the formula that we were just given, the general form for the nth term. So A is our first problem. Our sequence here is 3, 15, 75, 375, and so on. To find our ratio, or common ratio, we take a sub 2 over a sub 1. A sub 1 is the first term, a sub 2 is the second term. So here we will have 15 over 3, which gives us 5. So our common ratio is 5. Now we can find our nth term by taking the first term, which is 3, and we multiply it by the common ratio, which is 5, and we have n minus 1. There's our general term, or our nth term. Now if we take that, we want to find out where n equals 6, then we'll just copy down the 3, we'll copy down the 5. This is now 6 minus 1. This gives us 3 times 5 raised to the 5th power, because 6 minus 1 is 5. 5 to the 5th power is 3125. So we have 3 times 3125, and 3 times 3125 gives me 9375. So that is the 6th term of this geometric sequence. Let's do B. The sequence in B is 18, 6, 2, 2/3, and so on. So we can find the common ratio, which is what we need to do first. First off, A2, or the second term, is 6, and the first term is 18. So 6 divided by 18 gives us 1/3. So 1/3 is our common ratio. We can find our general term then by taking the first term, which is 18. We multiply by the common ratio, which is 1/3, raised to the n minus 1. We can now find the 6th term in this sequence by using our formula we just created. So we have 18, and we have 1 divided by 3, and we have 6 minus 1. That gives us 18 multiplied by 1/3 to the 5th power. Let's see what we have here. 1/3 to the 5th power is 1 over 243. So we have 18 times 1 over 243. And we can do some canceling, because 18 is really the same thing as 9 times 2, and 243 is really the same thing as 9 times 27. So we can cancel some stuff out. The 9s can cancel. And what are we left with? We're left with 2 over 27. And that is our 6th term of this geometric sequence. Let's try our last problem here. C is our last problem, and the sequence is 0.0004, negative 0.004, positive 0.04, negative 0.4, and so on. It just keeps going on like that. This is a little more awkward, right? But we can still do it. Let's find our second term, which is negative 0.004, and we divide it by our first term, which is positive 0.0004. When we look at that, if we multiplied top and bottom by 100, it'd move it twice, 1,000, move it 3 times, so 10,000. If we move the decimal place over top and bottom 4 times, we end up getting 40 over 4, which is a little bit easier for negative, by the way. Negative 40 over 4, which is a little bit easier for us to see what's going on. I mean, we could have just plugged that into our calculator, but it's kind of cool to see, to do it by hand and see how things work. So this is much more apparent. Negative 10. So negative 10 is our common ratio. So now we can find our common term here. We have our first value, a sub n, which is 0.0004 multiplied by the common ratio, negative 10, raised to the n minus 1. Now we can use this and find the sixth term of this geometric sequence. And we do that by having the first term, a sub 1, which is 0.0004, multiplied by negative 10 to the, 6 minus 1. This gives us 0.0004 times negative 10 to the 5. Negative 10 to the 5 is negative 100,000. 0.0004 times negative 100,000. It's kind of a big number. And then negative 100,000 times 0.0004 gives us negative 40. And that is the sixth term of our geometric sequence. That's it. Hopefully this was helpful. I hope you enjoyed it. Thanks for watching and have a good night.